arc length and sector area. Objective, find an assessment should be able to find the area of a sector, find the length of an arc. That's a typo. Okay. So if given a circle, if you're trying to find the length of an arc in degrees, all it really is just perimeter of a circle, right? Perimeter of a circle is 2 pi r to get the whole circle. Then you times by how much of the circle you actually want. So it's the angle divided by 360 because it's saying, oh, I want this portion of the circle. So multiply that by the perimeter and you get your arc length. Same idea for area. They're like, oh, area of a circle is pi r squared. I only want this portion of the circle, so put that over 360, and there you go. So it's very straightforward for degrees. But we're going to do this in radians now. And in radians, talked about it here, it's 2 separate formulas. Now the good news is that these are the formulas that are given to you, that IB does give to you. So these are the formulas in your formula sheet. They don't put the degree ones on there. These are not in your formula sheet. These are. So these are given to you in the IB formula sheet. So you just got to keep in mind that these only work in radians. It has to be in radians. And then it's very straightforward. The length of an arc is just r times theta. Area of a sector is 1/2 theta r squared. So there we go. So it's an example. A sector has a radius of 8.2 centimeters, an arc length of 12.3. Find its angle and the area. So we have the radius and we have the arc length. We want the angle. So arc length is this form right here. So let's write that down. L equals theta times r. Remember, it is in the formula sheet. Then plug in what you know. I know the arc length is 12.3. I know the radius is 8.2, so theta is what I'm looking for. And all you do is divide these two. And theta equals, let me bring up my calculator. Yeah, good job. 12.3 divided by 8.2. So you get 1.5. So there's my angle in radians, 1.5 radians. So again, that's in radians. Let's find the area. So area of a sector is pi r squared. Sorry, that's area of a circle. Area of a sector is this guy, 1/2 theta r squared. And again, I'm trying to find the area of that. So just plug in what I have. It's 1/2. My angle, which I just found, is 1.5 times the radius, which they gave me, is 8.2 squared. So again, let's put that in my calculator. So 0.5 1/2 times 1.5 times 8.2 squared. And I get 50.43. Now a lot of times in IB, you want to put it in 3 sig figs, so 50.4 is also acceptable. So there we go. So that's the general gist of it. Let's do a couple examples, just to, since I'm here. The end of a wall of a building has the shape of illustrated. So this is the end of a wall, where the center arc is AB. The center of an arc AB is at C. So here's the center of the arc. Here. So that's my C. Okay. Find alpha in radians to 4 sig figs. So we want to find what alpha is. So look at here, this is 30, so this must be 15 and 15. So if I'm just looking for alpha, I can use this triangle right here. Right, there's alpha, so this will be opposite over adjacent, which gets me 10, because TOA. So tan of alpha equals 5/15. We're going to do arctan on both sides. I get alpha equals arctan of 5/15. I'm going to use my calculator for that. I guess we're keeping radians, because we're going to keep in radians because we need it for the math. So let's do arctan 5/15. Again, this answer is going to be a little funky. It's going to be decimals, but it's because it's in radians. So 0.327. Or I guess 0.36 is 0.322. Again, because we're doing radians, that's the angle. So there's that. B, find theta in radians to 4 centimeter figures. Okay, so how are we going to find that? So let's look at the bottom here. Something like this, maybe something like this. Oops. We know this is theta. We know this is alpha. Alpha. Now, they both have the same values. This is 5 and 15, and this is 5 and 15. I mean, I kind of said this is alpha already, right? But these are equal because they're both like the same values here and same values here. So this is also 0.322. 0.322. So how do I figure out what theta is? Well, this full thing is 180 degrees, but we're in radians. What's 180 degrees in radians? It is pi. So the full line is 180 degrees, but in radians, that's pi. So we're just going to do pi minus these two. So theta is going to equal pi minus 0.322 minus 0.322. So my calculator is going to do pi minus 0.322 minus 0.322. And we get about 2497. So again, 3 sig figs, we put 2.50. So theta is about 2.50. So there's theta. Now we want to find the area of the whole wall. Okay, so why is this important? So the only way I can find this little arc here is if I do the area of a sector. So I'm gonna do the area of a sector to find this middle portion, and then I'm gonna add up the area of these two triangles. So that's how we're gonna do it. So to find the area of the wall, we're gonna do the area of the sector for this middle portion here, which is 1/2 theta r squared. Then we're gonna add up the area of these two triangles. And the area of the triangle is 1/2 base times height, and there's two of them. So 2 times 1/2 base times height. So plug everything in. Let's see, it's 1/2. Theta is, we just figured out, is 2.50. The radius, well, the radius is this guy. It's the radius, which I've not found yet, actually. So how am I going to find that? Well, it's the right triangle. So we're going to do a squared, b squared, c squared. So I'm going to go 15 and 5, and I got to find c. So 5 squared plus 15 squared equals c squared. Square root both sides. I should give myself more room. So I'm going to use my calculator again to get that. So square root of 5 squared plus 15 squared. So I get about 15.8. Alright, so that's value C, that's my radius. So I'll put that up here. I really don't have room. 3 sig figs squared plus 1/2 base times height, 1/2 base times height. But my base here is 15, my height is 5. So 1/2, 2 times 1/2, 15 times 5. Put that all together in my calculator. And we're going to get this monstrosity. Let's see, 0.5 times the rate, the angle, which we figured out was 2.5, roughly. And then let's see, the radius, which is this length, right? That's if I had a circle, that'd be my radius, which is 15.8. I'm going to square that one, plus 2 times 1/2, which is just 1, times the base, 15, times the height, 5. We get 387.5. Again, if we're doing 3 sig figs, 387. So there it goes. That's the area of the wall. Okay, let's do one more real quick. AT is a tangent to the given circle. So right there, when they tell you something's tangent, that means it makes a right angle. So that's a right angle. OA is 13. So give me the whole thing here. That's 13. And the circle has a radius of 5. So it means that this is 5 and this is 5, which lets me know this is 8. Find the perimeter of the shaded region. So I want the perimeter of the shaded region. Okay. So I need to find out, let's first find out this side here. Well, lucky for us, it's a right triangle. So it's kind of like this. This is 5, and this is 13. Now, there's a couple of right triangles you should know. Off the top of your head, there is 3, 4, 5. Oops, sorry. That's a right triangle, and there's 5, 12, 13. These are always going to be right triangles. So you can do the math on this if you want. 8, 9, 6, 8, 10, another big one. You can do the math on this if you want, but I'm telling you right now it's 12, right? It's going to be 5 squared plus b squared equals 13 squared. You're going to get 169 minus 25 is 144. And square root of 144 is 12. So this side right here, I'm telling you right now, is 12. So we have the 12, we have the 8. All we have to find now is this arc length. Well, to find the arc length, I got to figure out what angle that is. So how do I figure out what angle that is? Well, that's this angle right here, right? So we're going to use trig again. This is my angle. This is opposite. This is hypotenuse. This is adjacent. You have all sides, so you can use any one you want, actually. I'm a fan of sine. Let's do sine. So sine of my angle, let's call that theta, equals opposite of hypotenuse, so 12 over 13. So we're going to do inverse sine of both sides. Again, we had all sides. You use any one you want, really. These cancel out. Theta equals that. It's a mean radians. Again, I'm going to have to use arc length formula. Arc length formula is in radians, so 12 mean radians. 12 divided by 13. And we get 1.18 sig figs. So roughly, approximately 1.8. So there's my angle. And again, I'm just trying to find the arc length. And the arc length formula is r theta. So my arc length there for that purple part, for this guy right here, is going to be r, which is 5, times theta, which is 1.18. So, remember when perimeter is this, like, how do you enclose it? And I'm telling you, ask for perimeter, is how do you enclose the area? So you enclose by doing this arc here, this line here, and that line there. Like, that's a perimeter. Enclose the area. So I need to find arc length, which is this. I guess I'll put that in my calculator since I'm here. So 5 times 1.18. So you get 5.9. So L equals 5.9. We just got to add it to 12 and 8 to get the perimeter. So my perimeter here is equal to 5.9, which is this guy, plus 12 plus 8. So I get 25.9. And there you go. That's the lesson.